Alrighty. So again, a reminder for your lab number 5, it will be due sometime next week before the study day. I think on the study day, that'll be the last day for you to actually turn in the term work. So please check the deadline, right? Just don't miss the deadline. And don't forget, you gotta study abstract classes and interfaces. Okay. And already mentioned about the learning resources I made available on the lecture site on Recursion. You can check them out. It's going to be very useful for your exam, especially for the parts about the recursion. And the review session, again, the polling is going to close tomorrow. I'll try to send you guys a reminder. I'll try to remember that, but just indicate your availability before I choose the dates and time. All right, so this is new. I'm going to hold an optional Zoom session on Sunday. That's kind of the only time I can make. Anyway, if you're interested, come in. So what I plan to do on that tutorial session will be, I'll try to go over maybe one or two or maybe even more problems about recursion from coding that, right? So that's the learning side I kind of suggested to you. I will maybe go over several from there. And also maybe I go over maybe at least one from the past lab, which I also made available to you, right? We can go over some recursion. You guys can ask me questions. I can also share maybe some tips about how you can program with recursion, right? I think it's going to be useful. Tentatively 1 hour. If we have to go beyond that, we'll see. All right, anyway, 4 p.m. on Sunday, right? You already got a Zoom information from the e-class announcement. So if you're interested, join in. Your programming test number 3, I think the TA's grading are on track. So I think most likely I can give you the result and feedback early Monday. All right, so if there's any decision you have to make, you will also get a result by that time. All right. All right, any question about the course for me to clarify? All right, if no, let's now do some recap from last time, and then we'll continue about recursion. Okay, so last time we basically did some tracing about the factorial problem over here, which is a pretty easy one, but it's a very important one for you to really understand. So there are two approaches for doing tracing. Either you can go with a more like a lower level one using call stack, which is fundamental. You don't really use this kind of tracing approach when you're trying to design your recursive method, but it's important to know the basics. So what you normally do is to use this kind of high-level tracing. You start with the first method call and then go down to each recursive call until you reach the base case. That'll be the most effective way to really kind of informally see if your research method has been implemented correctly, right? That we'll see many examples coming as well. Well, we have done quite a bit last time on the strings, but today we'll see some example when we do recursions on the arrays. That's something we'll see today. All right, so you got to know how to trace on this call stack, also how to trace using this high-level approach. And we talk about common error. You want to make sure every time you have a recursive method, you have to include at least one base case, at least one. Otherwise, you'll run into infinite recursion. And similarly, you may also run into infinite recursion. Let's say you do have the base case, and you have some recursive call, but the recursive call itself does not really reduce the problem size. Right? You can see we got n here, we got n here. It's the same problem size. So you'll never reduce the problem size and eventually get to the base case. It's simply not possible, right? We kind of visualized that last time as well. You will also get infinite recursion. So these are the two common errors when you program in recursion. Just watch out for them. And we talk about this new problem here about Fibonacci sequence to figure out a particular number given some position, right? We did a high-level tracing here about Fibonacci sequence, fourth number on the sequence, right? We'll talk about it. That's a high-level tracing, which I will encourage you to also try maybe a bigger one. For example, you can try Fibonacci 8 to see how it can be done, right, using this approach. And as for the call stack tracing, I assign you guys as an exercise, which I think is important to really try Fibonacci of 4, all right? It's a very small problem here, but it turns out it's not trivial to really trace this one here. It is a very important exercise for you to try as well, right? I'm going to make sure I post the video solution. If you simply have no clue how to do it, I'll give you the video solution. And I'll expect you to really know how to do it before the exam. All right, so please, it's good for your learning. And then we talk about the strings because we do recursion on string. If you look at the coding bat site, they also do recursion on string, also recursion on the array. So we're gonna see both. But today we'll definitely go to the get to the recursion on the array, which is slightly more complicated, but we have time to explain that. All right, so for the string, you just gotta watch out for the substring method here. And the way to understand it, number one, you should visualize the array. Sorry, you should visualize each string as an array of characters. So it'll be from indices 0 all the way to the length of the string minus 1, just like normal array. And then whenever you pass any two inputs to the substring, just remember the second argument here is the exclusive bounds. The exclusive bound, meaning that if I put, for example, let's say 4 here, it really means I want to go for all the elements at index 0, index 1, index 2, index 3, and no index 4. So that one is excluded, right? We talked about it last time. And the special case would be if you got these two just the same, it will be empty string, all right? And also character add, right? You can also use that. And we spoke about two problems about recursion on string last time. Well, we'll do a final one today before we move on to recursion on the array. We'll talk about palindrome. We'll talk about reversal, right? Let me just talk about these two in general, right? When you are given, let's say, an array of character, which is a string, always think about how you can divide the original big problem into strictly smaller subproblem. Subproblem can be one subproblem, or can be two, or can be three. Depends. But in this case, when we try to pass, if this particular string is a palindrome, because by definition, reading forwards and backwards should be the same, so we try to look at the first and last character first. If they are the same, that means there is a chance for this string to be a palindrome. In which case, we'll try to look at a strictly smaller problem. And this strictly smaller problem is basically the original string with the first and last character truncated. So it's a strictly smaller problem. Right? So that's the first way to reduce the problem size. And when we talk about reversal over here, it's doing something similar, except that the way we try to create a strictly smaller problem is not really considering like a both character from the beginning and the end. We simply say, why don't we take the first character out and then simply assume we got a solution to the reversal of the remaining substring, and then try to put this guy here to the end. And that's how we combine them together, right? So I just want you guys to solve as many problems as possible, for example, in coding bat, so you will just get more and more feel about how you can divide the subproblems. Typically, once you know how to divide the original big problem into strictly smaller subproblems and try to combine the solution together, you got a solution. It's not really magic because everything will be executed by computer. It just will turn out it's a more natural way of thinking for certain problems. And of course, if you look at the code over here, I just want you guys to pay more attention to how we use the substring over here, right? And then we talk about high-level tracing. You can also go over that if you still have doubts. And some exercise for you. And the second problem we did was about the reversal, the reverse, all right? That's also the code over here. All right, there we go. And also, of course, we'll talk about the exam last time, all right? Any question about the what we cover on Tuesday about recursion? Any part you find kind of unnatural to you? You want me to explain more before I move on to the next problem? Alrighty, let's now do the next problem then. One more for recursion on the string. And let's look at some description here. All right, again, this problem here, it can also be solved by using a loop. So don't really get me wrong. I'm not saying that from now on, whenever you have some problem to solve, you will always try recursion before loop. Not necessarily. So in terms of the expressive power for these two mechanisms, either loop or recursion, they are basically equal. There is not a problem that you can only solve by using loop, but not recursion, and vice versa. So you can choose the one you need when you have graduated from this course. But in this course, we will be very explicit in the exam if we want you to solve the problem iteratively or recursively. Okay, let's now say we want to write a recursive method that's going to take a string, which can be empty, which cannot be empty, right? May or may not be empty. And there's another input, which will be a single character. And we want to count how many times the character appear in the string. I'm pretty sure you can solve this using a for loop. Very trivial, right? I'm pretty sure you can do that. But doing recursion is something we also want to train your recursive thinking, right? But just before I talk about the intuition, let's now make sure you really understand the input and output that's being talked about over here. Okay, so we're going to define a method called occurrences of. It's going to take some string, in this case empty string, and then take some single character A, right? You can see here A appears 0 times in the empty string. Any character will appear 0 times. So 0 returns an integer. And this one here, you can see there's only a single character. Also can be a base case. If you only got a single character there, just compare that directly with the second input character. If they are the same, you got 1. If they are not the same, you got 0. All right? Yeah, like here. How many times does A appear in this single character string? 0 times. All right? Let's now get a problem to be a little bigger. Let's say here. Let's say I got this string here, BAA. Now, how many times does A appear in that? I'm pretty sure you can count. It'll be 1, 2, and 3. Right? 1, 2 here, and also 3. Right? Easy to see. Right? Etc. Right? If you calculate how many times would be, it'll be 1 here, and also 2 over here. All right? Okay, and similarly for C. It's also possible for the character appear 0 times in the long string. Of course, you got to calculate properly. Any question about the input and output requirements for this method here before we talk about recursive solution? All right, so good. Let's now go to this page here, and then now we're going to talk about this final problem here about recursion on the string. The way to think about this would be like this, for example. I'm given this particular string, let's say. It's too big for me to solve right away, but at least I can test to see. Let's say I want to say, let's say this. The number of occurrences, let's say, of A. Let's say the second input to the method is A, for example. What I can do at least is to say, let me extract the very first character. I can do that right away. I know that A here is already equal to A. I know that I got at least 1 occurrence I can start with. And for the rest of the string over here, I don't know just yet. But because it's a strictly smaller problem, I can assume I got a solution to it by making a recursive call. And whatever number I can get returned from this recursive call on this strictly smaller problem, I just need to add up to whatever result this is for the first character. So what do I mean? Let me be more precise here. I want to count how many times A will appear in this string over here. So I will divide this string into 2 parts. This will be the first character. I can compare right away. So you can see over here, let's say, this is the first case, right? I want to see how many occurrences of A. I know that the first one here is already 1, because A here is just equal to A. All right? And then what about the remaining subproblem that's strictly smaller? The remaining problem will be what I highlighted in green, BCA. So what I want to do is I want to assume there is such a solution. And the way to assume is say, I got occurrences of, which is a method I'm going to define. I assume I got the solution here. And then I would say, I will pass the substring, in this case, BCA. And then I want to see how many times A is going to appear over there. Okay? Again, this part here is just the first character. It will be 1, at least 1. And this part here, I rely on what's going to be returned from this particular recursive call. When you do the tracing at a high level, it will just work. But for now, let's get the thinking right first, right? The strictly smaller problem in this case will be very similar to how we get a strictly smaller problem for the reversal case. That's why I put them side by side. All right? All right, any questions so far? All right. And then similarly, let's say I want to calculate the occurrences of B in that particular string. And I'll do something similar. Again, I will extract the first character here, A. A is not equal to B. So I know that as far as this part of the string is concerned, I got 0 occurrences. So what I will do is I'm going to put 0 over here, plus, and I still got this strictly smaller problem here. And then I would say occurrences of, and then BCA, and then B. Right? You can see in both cases, we got the same strictly smaller problem, BCA, which will be everything of the original string except for the first character. So it's guaranteed at some point in the recursion, we're going to reach the base case. Yes? Yes, indeed. So what Robert was suggesting is also a valid solution. For example, you can also do the following. You can give a try. You can say, I will extract the first character and the second character. Compare these two with A. So now in this case, I got A and A, so I got 2. The reason that we wouldn't do this, we wouldn't choose this one here is because it's going to make your code a little bit more complicated. For example, let's say I got A and A over here, right? I got 2 characters. They are not necessarily the same. Let's say we got A here, we got B here, and also I want to see the number of occurrences of C. Now you're going to say, if the first character is equal to this, I'm going to get 1. If this is equal to that, I'm going to get 1. So you'll get a more complicated if then else statement to write in the base case. In terms of the speed, it wouldn't make a difference. But I'm just saying that conceptually it could be slightly more complicated than necessary. So just extracting the first one is fine. But if you want to extract both of these and then try to see, you can get up to 2 occurrences in the base cases as opposed to up to 1. That's really the main difference. Otherwise, you should also be able to get the same result. Okay. Yeah. The base case, yeah, you can say that. Yeah, for sure. Yeah, you're right. I haven't talked about the base case just yet. You can, yeah, in this case for sure, if the base case will be, if the string is empty, then occurrence will always be 0. If the string size is 1, in that way, it depends on whether that character is the same as the character you're checking against. Right? Exactly. All right. Any other question about conceptually how we do the divide and conquer for this one here? Pretty straightforward one, right? Alrighty, and let's now look at the Java code very quickly. So we got a method here, occurrences of, over here. All right, and then we have some string and we have some character, right? So the base case, as Zach just pointed out, so here you can see it's empty, then just return 0, no matter what. That's good. So we don't even have a base case for 1. You don't need to, all right? And about a recursive case, exactly what I said earlier. So you can think about, we have a string over here, let's say S. Let's say S is the array of characters. So what we do is we try to extract the first character. Oh, it's called a head. So what I do is I'm going to put a head over here, and then the remaining part here will be the tail. All right, using the substring. So again, I'm going to let you guys to test yourself to convince yourself whether the substring has been processed properly. It is, but just be sure. And over here, we are doing some conditional here. If the head is simply equal to the C we are checking against, occurrence should be 1. Otherwise, it should be 0. And in both cases, we're also trying to make a recursive call, occurrences of. It will be the tail and also the character. Okay? So you can think about conceptually. Let me just do it one more time. Okay? If you're doing this, you want to say it will be 1 plus the occurrences of tail 1 here if the head is the same as the character we are checking against. And you can write another line. It will be 0 over here if they are not equal. All right? So one thing I think you guys should really appreciate is this. Don't really try to go to coding right away when you program in recursion. What I really suggest is to always try to sketch some idea based on the examples you know about the input and output. From there, think about divide and conquer, and after that, go to the coding. You'll be much more effective for long run. For simple problems, I agree, it might be easier to go to the coding right away, but you wouldn't get stuck in the simple problem stage for too long. All right, so That's something maybe I'll try to show you more when we get to the Sunday tutorial session. I'll try to give you maybe some more complicated problem too, go over together. All right. All right, any question? All right, so that's the last problem I would like to talk about for string, recursion on string. And if you look at the coding bat, I think they have more examples there. All right, you can take a look too. Okay, so let's now go over some concept and then we can take a short break. But the concept is important to get through first before we look at the problem. All right, so that's the number of occurrences we just talked about. All right, so now we're going to switch our input type from string into array. All right, so string is basically an array of characters. And the way we get a strictly smaller problem is by calling the substring method. But for the array, we don't have such method, like a subarray. You might actually go to the Java library to find something similar, but that's not something we're going to talk about. We're going to do it on our own, which is more effective. Okay. Also, conceptually, it's going to train us better for recursive thinking. All right, so we're going to talk about how we can make recursive calls on an array. Let me talk about some naive solution, which is not that space efficient, and then we'll move gradually to something that's more efficient. That's the main thing before we take a break. Okay, let's say this. Okay, I'll go on to the code right away. Okay, let's now consider this fragment of code over here. This one here is not really trying to solve a particular problem, really, but that one's to show to you if you want to make a recursive call on the input array. Let's say we got some integer array over here. And the idea will be for every recursive call, we're going to make the array strictly smaller. And the way to make a strictly smaller array is creating another array and copy the elements over, right? Let's now take a look, and then I'll give you some example. Let's now take a look at this code here. And the input is here. That's the input. So there are two base cases. If the length of the array is equal to 0, base case number 1. If the length of the array is 1, that's base case number 2. And we'll do something, right? It's more like a skeleton to show to you. And the else part over here is the recursive case, all right? So the recursive case, let's say we want to create a subarray. So what do I mean? Imagine that A here is the original array. So A is here, which will go from 0, 1, and 2, all the way to A dot length minus 1. Right? We know that pretty well. And what I want to create is a strictly smaller subproblem called sub. All right? Conceptually, what I want to do is this. I want to create a sub which is going to copy over from index 1 all the way to the last index. All right, you can think about sub. It's one element smaller, so it's strictly smaller. So it's going to be index 0, index 1, all the way to some last index. So think about index 0 of the subarray correspond to index 1. So index 1 of the subarray correspond to the original index 2 of the array, right? That's why it's one element smaller. The way to do it, I'll let you guys double check, right? Number 1, you can see a sub here is a new array of one element less, guaranteed to be strictly smaller. So we don't really have that second, like a first common error that we had, right? Second common error, okay? And then this part over here is simply trying to copy over the element. For example, we want to copy over 1 into 0, 2 into 1, and etc. That's exactly what this index, this variable assignment is doing, right? Check that variable assignment yourself, all right? It's actually working. And then we're making a recursive call on some strictly smaller problem. So this is the main line here. So this one here, let me make a note. So this is a recursive call on a strictly smaller array. And notice that there's no aliasing here. This array here and this array here, they're completely separate. All right? What does that mean? The number of subarrays you have to create corresponds to the number of recursive calls you have to make. All right? That's important to know. So that's why this naive solution here is okay conceptually, but it's very inefficient, which we don't want. But let's understand that one first, so we can transition ourselves into something that's way more efficient. All right, let's now run some tracing very quickly. If the input is simply A1, which is empty array, in that way, we don't need to create subarray because we simply reach the base case, right? Just that one. So this one is going to reach base case. So no array is going to be created, which is fine. Base case is always easy to execute. And then let's now take a look at this second one here. So we start with ABC. All right. So let's now do some tracing here. So what I want to do is I want to call M on A2. So M here is being called on this particular array. So A, B, and C. Of course, it's not valid Java, but you will understand. It's conceptual tracing. I'm trying to make a method call of N, which itself is recursive. And then the input here is an array of size 3, A, B, C here. All right, that's what we have. Let's now think about how things are going to work. This problem here at the moment is too big for us to process. So what we're going to do is create a subarray. So we're going to, in turn, make a recursive call and execute this loop over here. That one there is going to create a subarray, which is going to contain B and C. B and C. All right, so far so good. And then we're going to get another one. And that one there is also going to create a subarray of size 1, also C here. And you can see this one here of length 1 is reaching the base case. So we are done. All right. And this one here is the base case. So what does that mean? We have made number 1 and number 2 recursive calls. And we have created 1 and 2 subarrays. It's a very waste of the space over here every time we do it. And every time you're creating a subarray, you also have to execute some loop, which will also take some time. When we get to 2101, so this particular method here is going to take way more time theoretically than what we're going to show to you, the ultimate solution. So just understand that this solution here conceptually is not too bad, but it's a very bad solution in practice. All right. Okay, so let's make some remark over here. So the number of subarrays created is equal to the number of recursive calls. Okay, it's a very bad solution, space-wise and also time-wise. Very inefficient. All right, any questions so far about the naive solution? That's something you should not write in your code. All right, let's now show you the pattern that we need you to understand, and then we'll go over that pattern there, and then we'll take a short break before we see 2 problems. All right. So how should we do that? Call by value. All right. How does call by value help us? All right. You see, call by value is everywhere, right? So useful. The idea would be, rather than creating a new subarray and pass over to each recursive call, what we'll do is, why don't we say we pass the reference of the original array to the recursive call? No creating array, just pass the reference. And then we just need some extra integers to tell us which range of the original array are you going to look at. In the beginning, we want to look at from index 0 to index 3. In the first recursive call, index 0 to index 2, beg your pardon. Okay, that's the original call. But in the first recursive call, we're going to look at index 1 to index 2. The second recursive call, we're going to look at index 2 to index 2. So we just need to pass 2 integers to tell the recursive call in what range of the original array you want to look at. You never have to create any new array objects. That's kind of the conceptual idea. But let's now take a look. All right, so this is the ultimate solution pattern that you guys will have to use to solve the problems for the exam, right? That's the way to go. It's a very standard way. So the method here, M still, is still going to take an array And this array will never be duplicated, never, ever. And then we got two integers. We got something called from and something called to, right? You can feel free to call it x, y, I, j, doesn't matter, but from and to makes more sense. So the base case would be if usually from should be larger than, sorry, here. Okay, let me put it here. Non-base case is when the from is strictly less than 2. For example, you want to go from 2 to 4 or 5 to 7. On the other hand, when you actually got from is strictly larger than 2, it indicates an empty array range. And this is similar concept to what we talk about substring. Remember when we say 0 and maybe -1 or 1 and 0, right? That also represents an empty string. Similar, okay? But we'll go over example in a moment. So when this from index is strictly larger than 2, which is not typical, it simply tells you it's empty array range. That's base case number 1. All right, this is empty range. On the other hand, if you got from is equal to 2, that means maybe you want to go from 1 to 1 or 2 to 2. So it's only a single element in the array that you want to look at. So this one here is a single element range. And then, what about a recursive call? The recursive call goes like this. You want to call m, and you pass call by value, just pass a. And then you increment the from by 1. All right, and then 2. Let's now clarify this right away. Okay, I'm going to put it here. All right. Let's say we got our array, which I call A. Let's say this. Let's say second one here. Let's make it very simple. Let's say this is the from, and this is the to. All right. And so in the beginning, we want to cover the entire range conceptually. In the beginning, all right. Over here. And then when I try to make a recursive call by saying, oh, by the way, so when I start with, I'll say A, and then from, and then to. All right, A, from, and to. Let's say from happen to be the 0 index, let's say, okay? Now, how can I make a recursive call? The way to do it would be, I want to say A here, still, so I'm still just making an alias to it, call by value. And then from plus 1 and 2. If you go back here, you can see from plus 1 and then 2. What does that mean? That means the from plus 1 is going to indicate I'm going to go for a range starting from here all the way to the end. So this range over here is a strictly smaller sub-range. To run the recursion on. So the idea would be every time we make a recursive call, we're going to shrink this particular interval one by one until we get to the point that maybe we'll run until this one here. The range is only 1 element, or the range has 0 elements. Doesn't matter. Then we reach the base case. Conceptually, that's how that works. So you have to play with the indices cleverly, which I'm going to show you to you. Okay, quick recap. The efficient solution goes like this. You try to run the method, which is recursive, on some array. You have some from and to indices. Usually, the very first call you make will be from 0 to the last index. The very first recursive call you make will be you try to use the reference call by value to the same array. Don't create any new array. And then the from index over here will be incremented by 1. And then that effectively tells you, rather than looking at the entire range of the array from the original one, I'm now going to shrink the size of the range to look at this one instead. All right, that's the main bottleneck you have to get through. And one slight advice for later. Okay, In the example that we talk about in the class, I always try to increment from by 1. But when you actually get more familiar with this pattern here, you don't necessarily have to, number 1, always use 2 indices. You might find that enough just to use 1 index, number 1. Number 2, you may have to, for example, to say from +1 and 2 minus 1. That might work as well. Okay, just remember to be a little bit more flexible, to be more creative. Okay, that's for later, when you get more like proficient in this pattern here. All right, let's now do some very quick conceptual tracing, and then I'll take a short break, and then we'll go over 2 problems. Okay, let's say A1 over here is empty array. So the way to run the method here, we'll pass A1, the reference, and then I'll give 0. Let's say we always start from 0. That means we always want to cover the range starting from index 0. And then here, we're going to say A.length minus 1. Okay, that's the last index. But in this case, what's going to happen is this one here has the length 0. So A1, the length minus 1 is going to be minus 1. So this one, when you try to run it through this code over here, from larger than 2 is already true, right? 0 larger than minus 1. So that means it's the base case number 1. All right, so this one here is the from. And this one here is the 2. When from is strictly larger than 2, that's the base case you got to watch out for. All right? That's the base case. And let's look at the recursive case, which is interesting. All right? Let's do the following. Let me now, first of all, put A2 over here. Is going to be an array over here. So we got 0, we got 1, we got 2. We got A, B, and C. And then the method call we're trying to make is we say M, A2, 0. A2 that length is 3 minus 1, 2. So it'll be from 0 to 2. That'll be the very first call to make, right? And this one here, think about which range it's specifying. It's specifying basically this range over here from 0 to 2. That means to start the method with, we want to look at every element. Okay? And then, when we later try to make the recursive call, we're going to increment the from by 1. So the first recursive call is going to be n, and we still pass A2. So no new array created. And from plus 1 will be 1 and 2. So this one here, what range would it be? 1, 2, 1, 2. All right? So that means in the first recursive call, we're going to solve a strictly smaller problem from this particular sub-range, like a substring or sub-array. And the final one here, we'll try to do another one here, and A2. So 1 plus 1, which would be 2 and 2. And this one here, if you look at that, 2 and 2 is specifying this particular sub-range, right? And as you can see, that's reaching base case number 2 over there, right? You can see from is equal to 2 over here. All right, so this is base case. So this one here is the base case. Base case number 2. Okay, recap. For this pattern here, you start with basically the method call where you pass the reference of some array and the beginning and ending indices of the array from 0 until the length minus 1. And then when you make every recursive call, you're just going to shrink the size of the range over here. So we start with this particular range. And then by incrementing the from 0 to 1, we basically reduce the range into this sub-range that's strictly smaller. When you get to the next one, you go from 1 to 2 over here. That means you got an even smaller sub-range over here. And this one here has reached the base case. That'll be it. We don't have the need to create any array to waste the memory. And we don't have to run any loop to copy over the contents. Both are very bad. Okay? Any question about here? Okay? If everyone's good, so I would suggest we take a very short break, and then after break, we got 2 problems to go over. All right, you can now. All right, so before the break, we spoke about this slide here, namely slide 20, if you look at the recursion slide. So the bullet point here talks about a code fragment for the inefficient solution by creating a subarray. Please make sure you don't do it, but understand it conceptually is useful. And then we got this bullet point here. That's the efficient solution, right? That's the pattern we're going to instantiate for 2 problems. And then the past lab I made available to you, that one also used this pattern here. So you definitely can get more chance to practice. All right, good. All right, that's before the break. And let's now do 2 problems on the array. Right, they're similar, okay? So the first one may take slightly longer to explain. All right, so let's say we want to write a recursive method to determine if an array as the input of integers are all positive. All right? Okay, that's the problem itself is pretty simple, right? I will talk about the base case, number 1 here, a little bit later. But let's talk about other cases. This one here takes a little bit more explanation. Are all the numbers positive? True if yes, no, false. Are all the numbers here positive? Yeah. Sure, you don't see anything negative. So this one here should be true. And all the numbers positive, agree? True? Okay. This one should be false because you spot a violation, right? So this one here should be true, and this one here should be false. All right? And question for you. Empty array. Are all the numbers in the empty array positive, true or false? It's trickier than you might think, actually. False? No. True. Guys, be careful because if you got this base case wrong, you cannot get a green bar, right, for the coding bad. Okay. Now I need to explain this. It's actually not trivial. Have you guys ever seen this symbol before? 1090, 1019. All right, for all. Okay. What does the operator call? What quantifier? Anybody? If you have seen a universal quantification, universal quantifier, okay? If I say for every x, p of x, I basically want to say for all possible value of x in certain range, I want to know if all the elements there in the range satisfy some property p. And the p here is about being positive, right? Now, we have a special case over here. We're basically saying if x is in empty set, and I'm claiming that this one is an axiom or like a theorem, it will be equivalent to true. This is saying that if you say for every element in the empty set, you satisfy any property, it will always be true. That's the mathematical theorem, and we're applying it in the programming world. All right, that's something I want to first point out. And intuitively, can anybody justify why it should be true? If no, that's okay. I can tell you why. Oh, you want to say something? Go ahead, yeah. You're basically getting there. There's no element there, but let me add a little more complete. There's no element there to show the property is violated. So the property must be true. Yeah. You can also say that, yes, indeed. You basically say all elements in the empty set satisfy anything. That's logically true. Yeah. We'll talk about exist in a moment. Yes, we'll talk about exist. Yeah, that's for all right now. Yeah, go ahead. Yeah, because there's no number here, right? So that's why we try to go the other way. In order to prove something that's true, you will basically go for, if you try every possible way to prove that it's false. If you cannot, then it's got to be true. That's what we're doing here. It's like a proof you're trying to contradict something. If you find every possible way, but you still cannot contradict that thing must be true. That's what we're doing here. Okay? All right. So let me write down the justification for you, but this is because there is simply no something called witness in empty collection to show violation of the property. In this case, being positive, right? That's why it has to be true. Of course, you don't want to memorize this, right? I'm just saying that whenever you want to do recursion, very likely you have to talk about empty collection. And empty collection, you have to know whether it should be this case over here for all, or there's another way, there's another thing here. Let me talk about it as well. This will be some aside. If I change the problem into another province to say, is there some positive number right? You can see I'm now using another logical quantification because I'm talking about some existential. This basically can be boiled down into there exists some x and it satisfies some property. And we're talking about the x over here. Again, x is in the empty set. And this will be a little bit easier to understand. If you want to show that there is some positive number, show it to me. Can you give me a positive number from the empty array? No, you don't have anything there. There's no way to show that it's true, so it's got to be false. All right. So this will be false because no witness to show satisfaction. All right. No witness to show satisfaction. And here will be no witness to show violation. All right. So just be careful whenever you're asked to really program in recursion, or sometimes even for loop. Whenever you have some empty collection to consider, you want to really think about, are we really checking the all kinds, like a universal, or are we checking the some kind, like here, existential, right? The base case should be define different values, right? That's the main message right here. All right. And then, and if there's only one element, that's easy, just check it, right? And let's now talk about this one here. All right. Let's not even worry about the pattern that we spoke about before the break. We need to first understand how to break down the problem, right? And the way we break down the problem here will be very similar to the case of the string. If I want to know if all numbers in this particular array are positive, it's too big for me to tell right away. What I will do is, why don't I only look at the first one? If the first one is already negative, I can just return false, right? But if the first one is positive, like in this case, I should also bother to check the rest of the array, right? So we are already having the division part done. We check the first element here, and then look at the rest over here in a recursive call. And the way we look at the rest is by using from plus 1 as a sub-range, right? So this is what we're going to do. So think about what's going to happen over here is, if I say is, okay, so the method we're going to program is called all positive. And then here I simply got the array 4, 7, 3, 9. And then in the beginning, I'm going to go for indices 0, 1, 2, 3, right? I'm going to go from index 0 to index 3. Right? I'm going to look at the whole range. And how do I understand how this is going to be executed at runtime? For the very first step, what's going to happen is we're going to extract the very first element here, and then the rest is going to be passed on to recursion. All right? So the first one here will be A at index 0. Right? Index 0 here. Should be positive. Indeed, it is. And then we're going to use a conjunction here. Make a recursive call. all positive over here, and then we pass the same array. I'll just say A here. And then, rather than 0, we're going to look at from 1 to 3. So the main thing to really spot will be we got 0 here, and we got 1 here. So what we're doing is, in this initial call over here, we say we want to look at from 0 to 3. And then, in this recursive call over here, we say look at the same array, but from 1 to 3. So basically from 7 to here, right? Now, of course, the recursion might still go on. I'll do the detailed tracing a bit. I do have some diagram drawn already in the next page. But let's just make sure this is understood. Any question about this? That's a conceptual planning. All right, so this one here will be also very similar, right? We're just going to say whether 5 is positive, right? And then we're going to recur on the rest of the array. Very similar. Okay, but we're going to trace that in a moment. All right. Let's look at the Java code. Okay. And there is something that you guys will also need to get used to. Okay. So this is the pattern that we spoke about earlier. From and to. Typically, this method here will be made private because for anybody who uses your recursive method, they may not just want to specify something here directly by themselves in the first place. They don't really need to say, I want to go from 0 until the length of the array minus 1. This might be something you want to keep as private to your implementation class, right? For you as an implementer. So you will see that there's a pattern here. So we call this one here recursive helper method. So this is a recursive helper method. And typically, this one here should be made private. That means there should be another method there that's public for other people to use. And let's look at that. That one there will be this method here that should be public. And that one there is simply going to call the recursive helper method from 0 all the way to length minus 1, right? From the beginning until the ending indices, right? And for that public method here, you can see for any user, which in turn will use your recursive helper method, they don't need to be bothered with indices. They just specify the array, which by definition is going to be past 0 to the last indices anyway. Okay? That's important for you to note. That's more like a design issue, right? It's a very common pattern. So this is what a user needs to supply when using the solution. And the solution is indeed over here, but for them to use it, they don't really need to pass anything else, just the array. Okay, but in turn, it's going to pass 0 and 8 the length minus 1. All right, that's something you will see in the lab exercise I gave to you. All right, so here you can see when from is larger than 2, that's about empty range that we spoke about, right? The base case should be true. This corresponds to the true over here, okay? And then when you got a single element there, when from is equal to 2, and you should want to check to see whether index from should be larger than 0, just that particular index. And then the recursive case over here, let's now do a quick check. Think about this. Let's say this is our array. Let's say it's called A. Let's say from is somewhere in the middle. This is from, let's say, okay? And this one over here is the 2, which presumably should be the last index. So let's say at the moment we are supposed to look at everything from here to here. That's the from and to that we have. In order to make this recursive call, we are going to look at a strictly smaller range, which will be from plus 1 to 2. So the way to understand it will be, so here you can think about this is from plus 1 index, and that one there, this will be the new range that we need to look at here, right? So from plus 1 to 2. So that's the strictly smaller range we're going to recur on, all right? And that's it for the method. Okay. Again, you want to be very familiar with the pattern. Whenever we got these two, they are the typical base cases, either a range with only one element or a range with no elements. And when we got a range with more than one element, we're going to reduce the size of the range that we want to look at by one, which will be this sub-range. That's what we're doing by using from plus one. Everything will just work because of call by value, which we have seen quite many useful applications already, right? Okay. All right, any question about this problem here? Yeah. Yeah, I would say, yeah, helper method in general should be private, for sure. Yeah, should be. But since in your programming test lab, we don't really check, but just for good practice, go beyond this course. So I would say when you guys want to try out the helper method in general, just always make them private. Helper in the sense that is only help your internal implementation. You don't want other people to get access to it. Shouldn't be called, exactly, yeah, yeah. Over here, you only want user to call this method instead, only, yeah. Good question, thank you. All right, if no more question, let's go for one more. Okay. Yeah. Yes, of course. Sorry, say it again. I kind of missed the question. The first case, strictly speaking, may not be necessary. May not be. But I would say, okay, the pattern here kind of give you the flexibility. You got an empty range. You also got a range of only one element. Sometimes you might find that you don't really need this one here. Because if you only got one element here already, if you try to, let's say, from and to are already the same. When you say from plus one, it's going to reach this case in the next call. From will be larger than two. So strictly speaking, in some cases, this may not be necessary, but doesn't hurt. I'll leave the choice to you. Okay. All right, that's good. Let's look at one more problem. And if this one has been understood, the next one there is almost the same, right? Almost the same. All right, the next one here is checking to see whether or not the array is sorted. All right, so let's see. Oh, and now we can now try to see the base case right away. I'm asking if the array should be sorted. For example, 1, 2, 3, 4, 5 is sorted, or 2, 4, 6, 8, 10 is sorted. What about empty array? Is empty array sorted? It is, according to our logic, because you cannot find any violation case that is not sorted, so it must be sorted. Okay, think about that logic. It's a bit tricky, right? All right, empty array should be true. It's sorted. You cannot find any violation. 1, 2, 3, 4, sorted. And also 1, 2, 2, 1, 3, that's also fine. Because 2, 2, strictly speaking, is not really violating, so that's why we say non-descending. Non-descending simply means, okay, let me just put a note here. I'll put it here. When we say non-descending, so when you are trying to find any two elements, let's say ai and I plus 1. Okay, let's say I and I plus 1 are valid indices in the array. Okay, when you say non-descending, none here means negation. Descending means you're going strictly decreasing. All right, so that means this one here is strictly larger than that. So you're saying larger than and not the case. So think about this is not, this is descending. When not descending, if you can apply this one over this, it will be ai less than or equal to ai plus 1. So this one is really telling you, when I say non-descending, I'm basically including two cases. Either the two adjacent elements could be equal to each other, or maybe the left one is strictly smaller than the right one. All right. I'm just trying to show to you how it's derived, right? Non-descending. Okay. Okay, question for you. What about non-ascending? Something for you to work out. All right, think about it. Good. All right, we'll look at the code in a moment. Okay, so Okay, I forgot to really trace some cases for it. Let's now go over the sorted first, and then I'll get back to the tracing. Let's do that in that order. Okay, let's talk about this one first, and then I'll go back to tracing. Okay, are all the numbers sorted, right? So now we know that for this one here, it should be true. And for this one here, it should be true, right? Only one element. That's good. And this one here is interesting, all right? Now I want to see whether or not this array here is sorted, right? In order to check it, I need to look at, rather than just a beginning element, it's not enough. I need to look at least the first two elements here. For example, here, from 3 to 6, is it non-descending? It is. It's go from, because 3 is less than or equal to 6, right? So the idea to break it down would be, I want to, let's say this, index 0, 1, 2, and 3. I want to say A0 over here, which is 3, less than or equal to A at index 1, right? In this case, it will be 3, and it will be 6. This one should be true, and the rest of the array. And the rest of the array should be starting from here. Because if I start from here, I'm expecting the next one to check will be these two, right? And then these two, and etc. Okay, let me write it down first, and then we'll see if you got any question. So this will be another recursive call. So this will be is sorted. And then I'm still getting the reference of the array A. All right. And then I used to get, let's say, from and to. So let's say this is my original method call is sorted A here. All right. And then I got from 0 all the way to 3. 0 all the way to 3. That's what I start with. I want to look at the entire range. This one should boil down into, so this will be the from and from plus 1. Right? Look at the first two elements. And then when I try to recur, I should really recur from the second element onwards. I don't really recur from the third element. I don't want to miss the second elements. Okay? So this one here will be from this one plus 1, which would be 1. And then all the way to 3. So this is something that's important for you to note, right? We still go from to from plus 1. But just notice that for this particular problem, every time when you're calculating something here, you should look at two adjacent elements in the array. We'll do tracing, don't worry. I'll do tracing for both problems at one go. And this one here will be very similar. And this one, basically, when you actually made the recursive call on this particular level here, you can see 6 and 5, they are not sorted anymore. So at some point, you're going to return false. At some point. We'll see exactly how that's going to happen. But just understand that calling this is going to boil down into the first two elements check and some recursive call with a strictly smaller subrange. That's the main thing for you to see. Okay, let's look at the Java code, and then we'll do some tracing. All right, so we still have a recursive helper method here, and then we got a from larger than 2, empty range. In this case, should be true, and one element range, that should be true as well. All right, so these are good. And then when we call that recursive helper method, we go from 0 until the last index, right? Over here. And then let's now visualize slightly over here. So what we have is, let's say we got array A. Let's say somewhere in the middle we got from. Okay, let me also put from plus 1 here as well. And then we got 2. Okay, let's say that's what we have. Let's now take a look at what we're doing here. So this original call, A, from, and 2. So we are looking at this range over here, big range. And the way to make the recursion is by going for A, the same array, but it will be from plus 1 to 2. So that will be from plus 1 to 2 over here. And if you look at what's happening here, we're going to check to see A from less than or equal to A from plus 1. Check first to see whether these two elements are sorted. and then recur on this strictly smaller range over here to see if that's also sorted recursively, and then combine the result together using ampersand ampersand. We'll do tracing. Hopefully that can also help understanding. Any question about the code? We're good? Okay, take some time, right? Okay, we still have some time. Let's now do some tracing. Okay. Let me now go back to the it's all positive, right? When we go to it's all positive, let's say A is simply empty array. In that way, when we call it's positive, and then calling the recursive helper method, we're going to pass 0 and also 0 minus 1, which will be here. And then that one there is going to reach from larger than 2, because 0 larger than minus 1. So it's going to return true. So this one here has no chance to reach the recursion. All right, so this one here is just going to return true. And it'll be the same case for all sorted, right? It's sorted method as well. All right, the next case over here. Let's say we got A, let's say it's 4. It's all positive. We'll be calling this public method here. And then over here, we're going to make a recursive method call. 0, A.length, which is 1, minus 1 will be 0. So that's why you see 0, 0 over here. And then this one here will reach the base case right here, because from is equal to 2, right? From and 2, they're both 0. So you're only going to check to see whether A0 is larger than 0. Indeed, A0 is simply 4. Larger than 0 should be true. All right, that's another base case. Okay, let's look at this one here. And then I got another one here left as exercise for you. I'll leave that clean. All right, let's look at this one here. And I already got a high-level tracing set up already. We just need to go over the detail. All right, let's now take a look. And I'll try to, so the array we are doing is A4739. So 4, 7, 3, and 9. Indices will be 0, 1, 2, and 3, right? That's the array we're having. There's going to be only a single array, no duplicates in the between the recursive call. So let's now start with this. This is the initial call. And then 0, A.length minus 1, which would be 3. That's the last index. So this particular recursive call is going to cover from 0 to 3. That's how we start with. And that one there is going to boil down into A at index from, which is here, right? The first index, larger than 0. And then we can make a recursive call here. That one there is going to do from plus 1, 0 plus 1, basically. So that's going to be from 1 to 3. That one there is the second call here, 1 to 3. All right. Used to be from is equal to 0, but it's now from is equal to 1. And then that one there, we're going to see A1 larger than 0. And then we're going to make another recursive call here. That one there is going to be from, which is 1 plus 1, which will be 2, right? That one there is going to be this one here. And that one there is also going to reduce the range further from 2 to 3 over here. And for that particular one, the from will be index 2. So we are looking at this element here. So that's why you see A2 larger than 0, which is also true. And then that one, they will make a final recursive call by incrementing from the from value from 2 to 3. So that one there is going to be looking at only this element here. And when you get to that particular case, you're going to reach from is equal to 2. And when you're looking at this, you're only going to check whether that particular index element here is larger than 0. Indeed, it is. Okay, so this one will boil down into A at index 3 is larger than 0. All right, you will see that all these will just boil down into true. And we're combining them using ampersand, ampersand. Combine them together, you get true. Yeah, so you can see, really try this high-level tracing structure here is very useful to see exactly how things work. All right. So I just didn't put n%, but I can put it now. All right, so after this page over here, take a look at this one here and see why this is going to return false from the tracing. All right, that's for you. All right, I already set up the structure for you already, pretty much. You just need to follow through, print it out, and try to trace the code. Okay, let's do one more. Okay, for the assorted problem over here, the base case empty array will be the same as before. I'll leave that to you. And also for the one element array, also the same. In that way, you have to look at basically this one here, right? That's a base case, should be just true. Let's look at just this one here. Oh, how about this? This one here, exercise for you, but we'll look at this one here because that one is going to return false. How about that? Okay, look at this one here. So we got 3, 6, 5, 7. So A here, we got 3, 6, 5, 7. 3, 6, 5, 7. Indices 0, 1, 2, and 3. All right. And the way we combine the result with the recursive call is by using conjunction, right? So every level we're going to use conjunction. Let's now try. We start with is sorted, and then it's going to pass to the recursive helper method over here, and then from and to. In this case, it will be 0 and 3. That means we intend to cover the entire range over here, okay, which is good. That one there is going to boil down into this case over here. So A at index from, which would be 0, from plus 1 would be 1. So we're looking at these two elements. So that's exactly what you see over here. So this one will be 3 and 6. And this one here is going to give you true. And notice that we're using n%. So short circuit tells us we'll only continue if this is true. Indeed, it is. So we should really go for this recursive call. And that one there is going to be calling from 1 to 3. You can see 0 to 3, and now it's 1 to 3. Okay, and then, so that will be basically this sub-range here. That's strictly smaller. And then, this will again boil down into this recursive case. And from and to. So 6 and 5. 6 and 5. 6 less than or equal to 5 is actually false. And then we are actually using the n% over here. So short circuit tells us we actually don't need to go any further. We are done. No further recursion necessary. So this part over here, in practice, is not going to happen. Bypassed. So what's going to happen is, since this one is already false, overall it's going to be false. All right? So just remember the short circuit evaluation. All right, so your exercise is try maybe this one here with all the way true. So that one there is going to hopefully reinforce your understanding. All right, so what we covered today, we did one more problem on the recursion on strings, and most importantly, we introduced to you this pattern for recursion on the arrays. Make sure you go over the two examples we did, and also the lab exercise I made available to you. Also take a look. And on Tuesday, since we are doing pretty well in the time, so I think we can do one interesting problem on recursion, which will be the last class, right? And I'll give you some background information here. Have you guys heard about the Tower of Hanoi? Let's cover this on Tuesday. It's a fun problem to work with, all right? That one there is some interesting story, and then we'll do some Java code as well. I'll make it available to you, and then we'll play with that on Tuesday, last class. So guys, make sure you review the recursion, inheritance, everything, and then I'll confirm about the review session pretty soon. All right, see you Tuesday.